So today we're going to talk about some things called permutations and combinations. So a permutation is an arrangement of things where order matters. And so these are going to be word problems most likely. And so you need to be able to understand if order matters or order doesn't matter. So I'm going to give you some keywords for permutations. So if it says the word order, unless it's followed by order doesn't matter, then we are to assume it does matter. So order would be a permutation. If it says the word ways, like how many ways can I do something, that's also a permutation. If it talks about races, like a horse race, it matters what place you come in, if you come in first place or if you come in last place. So order matters in that. Also, that would be like an election. An election is a type of a race. It matters who comes first and can be president. Also, if we're talking about words, order matters when you're making words. If you have the two letters O and N, it matters if the O comes first. If the O comes first, it's on. If the O comes second, it is now no. So it matters what order it goes in. So the calculated directions is, if you see this NPR right here. So that's the notation. N is the number of things you're choosing from, and R is the number of things you're choosing. And so you can use your calculator for this. It's pretty easy. And what you do is you have to type the N, then you have to hit the math button, arrow over to where it says PRB in the heading, type 2, and then type the R. So it says, out of 5 colors of M&Ms, how many different ways could you eat 3 of them? So you have to first decide, well, how many colors of M&Ms do I have to choose from? Well, I have to choose from 5 of them. That's the total that I have. And it says the word ways, so that's how I know it's a permutation. And how many ways you could eat 3 of them? 3 of them is the number of things you're choosing. The first number will always be bigger or the same as the second number. It can never be smaller. You can't choose more things than you have. I can't choose 5 things from only 3 available things. So now I'm going to grab my calculator. And so what you do is you type the 5, then you hit math, and you arrow over to where it says PRB. And then you should see right there NPR is number 2. And so it pulls it up, then I write 3. So the answer is 60. So if I had 60, or if I had 5 colors of M&Ms, there's 60 different ways I could eat 3 of them. So then it says, what is the total permutation for 8P3? So that one's already written out for me. So I just get my calculator and I do 8, hit math, go over to PRB, hit number 2, and then type in the 3. And I get 336. So then a combination is an arrangement of things where order doesn't matter. So the calculated directions are similar. You type the N, you press the math button, arrow over to PRB, press number 3 this time, and type the R. So the next one says, out of 5 colors of M&Ms, how many combinations of 4 could you eat? So combination is a good way to see that it is a combination. Some other keywords, if it's talking about food, that is generally a combination, because when you get food, it doesn't really matter what order things go in. If you're getting a chocolate sundae, then they may throw the sprinkles on first and then the M&Ms. It doesn't matter. They just throw it all on. With a pizza, it doesn't matter if the mushrooms goes on first or then the pepperoni. It doesn't matter. So food order doesn't matter. Also, if we're talking about the lottery, I'm sure there's some lotteries where the order matters, but we're going to assume for all the problems in here, unless it tells you otherwise, that order doesn't matter. Also, if we're talking about any kind of groups, like whenever I put you in groups in class or a teacher puts you in groups, they don't care what order they're putting the group in. They just throw you on a group and call it a day. So it says out of 5 colors of M&Ms, so 5 is how many we have to choose from. That's the bigger of the 2 numbers. It's a combination because it says it, and the smaller number goes second. So then I grab my calculator, and I type the 5 first. Hit math, go over to PRB, and now I'm hitting 3 this time, and 4. And I get 5. Alright, now we're going to do the one on the bottom. This one just gives it to us. So 4. Oh. And then number 3. 3. And that is number 4. Okay, moving on to some problems. So Julie's choosing 6 of her 7 senior paintings to submit to college in her art portfolio. How many different sets of paintings could she submit? And so you need to be looking for the keywords. So different sets of paintings, I would say sets as a type of group. You could also just put yourself in Julie's position. If you were submitting 6 out of your 7 paintings, would you care what order they're put in? No, the college would not care what order they're put in. So that means this is going to be a combination. Then you pick the larger of the 2 numbers, so she has 7 paintings to choose from, and she's choosing 6 of them. Okay, I'm going to go and do this on the calculator all at once, so I'm going to fill it out. So Ken is choosing and ordering 7 people to speak at a conference out of 15 applicants. So it says the word order, so that's a permutation. That's one of my keywords. I put the bigger number first, the smaller number second. Next one, how many different ways? Ways is a keyword for permutation. You rearrange the letters in the word Barbie. So this doesn't have any numbers in it. So what you got to do is you got to figure out how many letters you have to choose from. So I count the amount of letters, B-A-R-B-I-E. So I count that up, and there are 6 letters there. And I'm rearranging it into, we are going to assume, other 6-letter words, unless it said otherwise. Next one, how many different places can 9 horses come out in the end of a race? A race is a permutation. I have 9 horses to choose from, and unless one of them dies, 9 of them will finish the race. The last one, a Senate committee is choosing a 5-man subcommittee from 13 committee members. Assuming that the president of the committee must be in the 5-man subcommittee, how many different subcommittees? So this one's a little bit tricky, and I won't be giving you many of these. So the first thing is it's a subcommittee. That's a group. So that's a combination. And so the thing that's tricky about this is that the president has to be in each 5-man subcommittee. The president is part of the 13, and so if there's 13 people, but the president counts as one of them, but he has to be in every group, we only actually have 12 to choose from. And in each subcommittee, there's 5 men, but one of those spots is taken by the president. So really, there's only 4 spots to fill. So now I'm going to grab my calculator, and I'm going to do all of these problems. So I put the bigger number first. Combination, 6. The first one, the answer is 7. The second one, the next one is quite a large number, 32,432,400. The next one is 720. Then we got 362,880. And then the last one is 495. So that is the answers to all of these. You will be having a video quiz tomorrow in class. So your word for the video quiz is monkey. So write it down.